Example 3 gets us back to our imaginary numbers. We've seen these recently, and I think lesson 51 is our first look at imaginary numbers. Now we've been simplifying them for a while. First thing, I notice i's to powers, and you might recall that I to the first power is I, and I to the second power is -1, I to the third power is -I, and I to the fourth power is +1. I to the fifth power takes you back to I to the first power, and so on. It's a repeatable pattern. The key to I is that I to the first power, or real numbers, are all we want for all of our terms. And then we combine like terms once we've done that. For me personally, if I start seeing radicals within a problem involving imaginary numbers, so if you start seeing i's showing up in your problem and there's radicals, square root symbols in there, the first thing I'm going to deal with is any negatives in the radicals. That's the first thing. I don't deal with i's to powers until I've dealt with all the radical issues. So I'm going to write down 4i cubed minus 2i to the fourth again and again and again until I get these radicals as simple as possible. The first issue with radicals is negatives in the radical. The rule, square root of -1 is equal to I. So anytime I see a negative in a radical, that creates an I outside the radical. So notice that's a positive I it equals, right? Square root of -1 equals a positive I. So this minus inside this radical becomes an I outside the radical, and it's still the square root of 9. Okay? It does not change the sign in front of the 2. Some of you are doing that. I don't know, I never said that, but maybe you weren't paying close enough attention when I didn't say that maybe you started inventing stuff. But the negative in the radical creates the positive I outside the radical. So be careful of that. I'm going to keep it the square root of 9 for right now. Right here, the square root of -3, the square root of -3. I times the square root of 3 times I times the square root of 3. Each negative inside the radical creates a positive I outside the radical. So again, this stays plus, this creates an I, this creates an I, and once you create the I's, the 3's become positive. Alright, that's the first priority. Always deal with the negatives and the radicals, get those negatives out of there, so everything is just either I's or no I's, whatever, but all the radicals are going to be square roots of positive numbers. We want that to happen. Second step, what's the square root of 9?
3.
Notice 2i is being multiplied by the square root of 9, so 2i is being multiplied by 3. All right, what's the square root of 3 times the square root of 3?
3.
Also 3. All this stuff's being multiplied, so all that stuff, 3 is being multiplied by I and I. So, again, that's another thing I've noticed people doing. You take a product and when you start taking the i's out, all of a sudden it becomes 3 plus I squared instead of 3 times I squared. So be careful that the structure doesn't get compromised when you're going through the process is what you're doing. So if I go ahead and one more step here just to get this stuff all prettied up before I start worrying about the i's to powers. 4i to the third power minus 2i to the fourth power, just rewrite it. What does this term become?
6i.
Plus 6i. In this term?
3i.
Plus 3i squared.
Squared.
Right. Right. So go ahead and get everything down to just whatever they are, i's to whatever powers. I don't care about that stuff. I just want to get it as simple as possible before I start worrying about this stuff here. Okay? So in general, I want every problem to look like this before I focus on this. Take your time, be patient, and go ahead and get working. So at this point, I start substituting in. Now again, focusing on structure. What's happening to 4 and I cubed? They're being multiplied. So when I replace I cubed with a negative I, that 4 is being multiplied by I cubed, so 4 is being multiplied by negative I. Minus 2i to the fourth, 2 and I to the fourth are being multiplied. So when I replace I to the fourth with a 1, negative 2 is being multiplied by a positive 1. 6i is perfectly fine. If you have I to the first power or real numbers, nothing happens in this step. 3i squared, 3 and I squared are being multiplied, so 3 is going to be multiplied by its replacement, negative 1. That's another thing that some of you are doing wrong on these problems. When you do your replacements, I cubed out of the fourth and everything with numbers, you change multiplications into additions and subtractions. Be careful that you don't do that. These are being multiplied, you substitute, they're still being multiplied. Multiplied, still being multiplied. Multiplied, still being multiplied. And if I simplify each object individually, that's negative 4i, that's negative 2, that's positive 6i, that's negative 3. What order do I want on these, on a final answer? PJ?
Constant numbers and then imaginary first.
Reals first, than imaginaries. That's what we want, right? So when I go to actually add like terms at this point, all I'm left with is imaginary numbers or real numbers. I want the real sum first. Negative 2 minus 3, they're the same sign, so I add, negative shared, so it's negative. Imaginary second, 6i minus 4i, they're different signs, so I subtract, and 6 is bigger, so it's positive. So negative 5 plus 2i is the outcome I'm looking for there. Okay, I'm not counting it wrong if you put 2i minus 5, but again, I'm just telling you where we're going with this. That order is better than the other order. So if you go ahead and create a habit now of doing it in the right order, you'll save yourself some headaches down the road.